Find the values of x and y. Looking at the diagram, you can see that PQRS is a parallelogram because the opposite sides are parallel. So by the parallelogram opposite sides theorem, SR equals PQ. So substituting in the given information gives 3y minus 1 equals 20. Then adding 1 to each side gives 3y equals 21. Dividing by 3 on each side gives y equals 7. By the parallelogram opposite angles theorem, the measure of angle P equals the measure of angle R. So substituting in the given information gives 2x equals 54. Dividing by 2 on each side gives x equals 27. In parallelogram PQRS, y equals 7 and x equals 27. In the parallelogram PQRS, the measure of angle P is 4 times the measure of angle Q. Find the measure of angle P. So look at a parallelogram PQRS. Let the measure of angle Q be x degrees. You are given that the measure of angle P is 4 times the measure of angle Q. So the measure of angle P would be 4x degrees. Notice that angle P and angle Q are consecutive angles. So by the parallelogram consecutive angles theorem, angle P and angle Q are supplementary. So the measure of angle P plus the measure of angle Q equals 180 degrees by the definition of supplementary angles. Substituting in the given information gives 4x degrees plus x degrees equals 180 degrees. Combining like terms on the left side gives 5x degrees equals 180 degrees. Then dividing by 5 on each side gives that x equals 36 degrees. Now recall that the measure of angle P equals 4x degrees. So substitute 36 for x, which gives the measure of angle P equals 4 times 36 degrees. So the measure of angle P equals 144 degrees. Use the figure. Use the figure. Write a 2-column proof. Given A, B, C, D, and G, D, E, F are parallelograms, prove angle C is congruent to angle G. Begin by setting up your 2 columns. A, B, C, D, and G, D, E, F are parallelograms because this was given information. Then looking at the diagram, Notice that angle C and angle CDA are consecutive angles, and angle G and angle EDG are also consecutive angles. So angle C and angle CDA are supplementary, and angle G and angle EDG are supplementary by the parallelogram consecutive angles theorem. Also, angle CDA and angle EDG are vertical angles because their sides form two pairs of opposite rays. So angle CDA is congruent to angle EDG by the vertical angles congruence theorem. Then angle C is congruent to angle G by the congruent supplements theorem, which says that if two angles are supplementary to the same angle, then they are congruent. Find the coordinates of the intersection of the diagonals of parallelogram ABCD with vertices A10, B60, C53, and D03. Begin by plotting the points A10, B60, C53, and D03. Then connect the points using line segments, and draw your diagonals. By the parallelogram diagonals theorem, the diagonals bisect each other. So the coordinates of the intersection are the midpoints of the diagonals, line segment AC and line segment DB. So find the midpoint of one of the line segments. So the midpoint of line segment AC equals 1 plus 5 divided by 2, 0 plus 3 divided by 2, which equals 6 divided by 2, 3 divided by 2, which equals 3/3. So plot this point on the graph. So the coordinates of the intersection of the diagonals of parallelogram ABCD are 3/3. Three vertices of parallelogram DEFG are D-1, 4, E2, 3, and F4, 2. Find the coordinates of vertex G. Plot your points D-1, 4, E2, 3, and F4, 2. Then connect the points using line segments. Find the slope of line segment DE. Because DEFG is a parallelogram, opposite sides must be parallel. So the slope of line segment DE equals the quantity 4 minus 3 divided by the quantity -1 minus 2, which equals 1 divided by -3, or -1/3. So the slope has a rise of 1 unit and a run of -3 units. So start at point F and go over 3 units to the left and 1 unit up, and plot point G, which is 1, -1. Then connect the points using line segments. Notice that line segment DE is parallel to line segment GF because they have the same slope. Now verify that line segment EF and line segment DG are parallel. So the slope of line segment EF equals the quantity 3 minus -2 divided by the quantity 2 minus 4, which equals 5 divided by -2, or -5 halves. And the slope of line segment DG equals the quantity 4 minus -1 divided by the quantity -1 minus 1, which equals 5 divided by -2, or -5 halves. Thus the coordinates of vertex G are 1, -1.